We got Mary. She's crossing a 200-meter river. All right, so the distance from here to here is 200 meters. And it's flowing east. All right, so the river, the velocity is moving at 1.5 meters per second. She can row with 3.8 meters per second, and she's going to go due north at 3.8 meters per second. What is her... these are the answers. What is her speed? How far from her intended landing spot will she be? And then what is her speed? I actually solved for the speed first. I don't know. I'll do it that way. So if this is 3.8, we're going to add these vectorially, and this is 1.5. Then what's her overall speed? Her overall speed is the hypotenuse of this triangle, right? So it's going to be 3.8 squared plus 1.5 squared, Pythagoras square root, and I got 4.1 meters per second. So that's how fast she will actually be traveling, because the current is going to help her along. So her 3.8 increases to 4.1. Now, what I needed to do, though, to solve this first part is I found what this angle was. So if I have a velocity and two velocities, I can find that. So I said tan -1 equals 1.5 over 3.8, or tan of -1 of 1.5 over 3.8, and I got an angle of, what was it, 21.5 degrees, right? Because tan theta is 1.5 over 3.8, and you use the -1 function on your calculator, and I got an angle of 21.5. Then I said, well, I go new triangle, and I'm trying to find this. If I know that this is 200, and then this right here is 21.5, I now use tan of 21.5 is equal to the opposite. The opposite is x. X over 200. And when I solve for x, I do just simple algebra. I get about 78.8 meters. You might just round that to 79 meters.